Hey everybody, thank you for joining us in this video on FY6 Classroom, where the F in physics stands for fun. If you get value from this, I appreciate the like down below. And if you really like this and you want to see more videos, go ahead and hit subscribe. Anyways, today we're going to be talking about Newton's first law. And Newton's first law has a bunch of misconceptions, and a lot of people seem to struggle understanding it and getting a good grasp on it. So the purpose of this video is to hopefully give you a really good understanding of Newton's first law. So the definition of Newton's first law is an object at rest will stay at rest and an object in motion will stay in motion. And that's where most people stop. And I think that's the reason why there is a very large misconception about Newton's first law. They say an object at rest will stay at rest and an object in motion will stay in motion. And they don't even put in the most important part of Newton's first law. And that most important part is that an object in motion will stay in motion, object in rest will stay at rest, unless acted on by an unbalanced outside force. And the whole thing is Newton's laws is talking about how objects move and how their motion changes. That's the whole point of Newton's first law. So you see, I put the letters in red and I underlined the most important part of the law is that these objects that are at rest or these objects that are in motion, they're going to continue that way unless there is an outside unbalanced force acting on it. And to talk about Newton's first law, I want to show you the space brick. Now, I talked about space brick in a previous video, and space brick is just a brick that is in space. Now, the reason I choose a brick is just because it's an object that people are familiar with. And the reason why I put it in space is because space is the best place to describe Newton's first law. So in space, there is nothing. It's a vacuum. And if you think about space brick, just existing in space, you might get a really good understanding of Newton's first law. So let's take space brick and let's say it's just sitting in space, not moving. So it has a velocity of 0 meters per second. And if it has a velocity of 0 meters per second, that means it is an object at rest. And since it's an object at rest, it's going to stay at rest. And it will stay at rest forever. It will just sit there unless some sort of outside force acts on it. So let's pretend that we have some sort of green meteorite that's floating around in space, and this can be an outside force. It might crash into space brick, and if it crashes into it, then it's an outside force, and that outside force is going to change its state from rest to motion. And that's the only way that space brick is going to begin moving is if there is some sort of outside force acting on it. And so that's whenever we talk about an object at rest will stay at rest unless acted on by an outside and unbalanced force. Now let's change it up a little bit. Let's say it's not moving at 0 meters per second anymore. Let's say it is moving at, let's say 10 meters per second, and let's say it's moving to the right. Now space brick is going to continue moving at 10 meters per second in that direction forever. And that's something that's hard for some people to understand. But if you think about it, why would it stop? There's nothing in space to stop it. I mean, I suppose it could crash into a planet, but the odds of that are very unlikely. And if it does crash into a planet, well, that's an outside unbalanced force. So anyway, space brick is going to continue at 10 meters per second indefinitely. So an object in motion will stay in motion unless acted on by an unbalanced outside force. So if we had this piece of space debris and it crashed into the front of space brick, it has the potential to stop it. And this is what Newton was talking about when he was bringing up his first law of motion. An object at rest will stay at rest, and an object in motion will stay in motion unless it's acted on by an outside and unbalanced force. Now, we talked about this piece of meteorite being an outside force, but what do I mean by unbalanced? If you notice, I even bolded the word unbalanced. And to explain the unbalanced part, I'd like to bring up this other diagram, this diagram of a car down here. And this is a more realistic explanation or example of forces that we're more familiar with. You see, on planet Earth, we're used to seeing things moving, and then eventually they just stop moving. And the reason why things stop moving is because there are outside forces acting on an object. So let's take this car right here, and let's say that it is applying a force forward, and that would be the force applied. That would probably be from the engine. So the engine is creating a force forward. And if this was the only force acting on this car would have an unbalanced force. But let's say that friction is working on the car. So we would have a backwards force of friction that is equal to the force that is being applied from the engine. So force of friction is equal to the force being applied by the car. So we can say the force applied is equal to the force of friction. Now, in this case, the forces are balanced. And if the forces are balanced, that means there is no change in motion. So that means if the car was moving initially and then all the forces balanced out, then it's going to keep moving. An object in motion will stay in motion unless an outside unbalanced force is acted on it. Now, let's say the force of friction is now greater than the force applied. So if the force of friction is greater than the force applied, that means the object is going to be slowing down. And the reason why it's going to be slowing down is because the backwards force is greater than the forwards force. Now, if the force of friction was less than the force applied, then the car will be speeding up. So force of friction is less than force applied, so speeding up. And the reason why it'd be speeding up is because there's more force from the engine than friction from the road. And this is an example of an unbalanced force. So the car was in motion initially, but because the forces are unbalanced, the motion is actually changing. And in this particular example right here, the motion is changing because the car is speeding up. It's in motion, but there is just more motion now. But if we were to just ignore all these different forces right here, and let's say the car was just at rest, it wasn't even moving. So if the car is at rest, it's going to stay at rest unless there is some outside unbalanced force acting on it. Anyway, thanks for watching, guys. I hope that helped clear up Newton's first law a little bit, and I'll see you in the next video.